For a problem like this, we're trying to find the slope of a line, and they give us 2 points. And so we want to use the following formula, which is right here. You subtract the y values on top and subtract the x values on bottom. That gives you the rise over the run. You may have heard of that, or the rise is the change in the vertical direction up and down, and the run is the change in the horizontal direction sideways. So we'll start with this point. You do that point's y value, which is negative 16, and subtract the other point's y value, which is a positive 16. So you get negative 32 on top. On the bottom, make sure you start with the same point. So we use this point as our first y value. Make sure you use that as the first x value. So negative 10 and then minus 6, you get a negative 16 on bottom. And that would actually reduce to a positive 2 if you reduce that fraction down. So the slope of this line is 2. And I just have a really rough graph of it here. Negative 10 and the x, and then negative 16, that's the first point. And the second point was a positive 6 in the x, and then a positive 16, that's the second point. And so if you counted in the y direction, from this point up to that point, there are 32 spots. If we had all the tick marks drawn in. And then in the x direction, there are 16 spots. If you count it over from 10, you'd get 10 spots and then 6 more for 16. So that's really what we're doing, is just counting the change in the y, and then on the bottom, the change in the x, and we reduce that down to 2. To kind of expand on that a little more, a slope of 2, you can reduce it to 2, but if you think about it, always keep the slope in your mind. Think of it like this, where it has a vertical change and a horizontal change. So 2 is really 2 over 1, which means from any point on the line, a top number tells us that we can go up 2 and over 1, and we'll still be on the line. So the top number in the slope tells you how far to go up, the bottom one tells you how far to go over. So like if we were on this point and we counted up 2 and then over 1, we'd still be back on the point here, or on the line here. Up 2 from negative 16 would be negative 14, and over 1 from negative 10 would be negative 9. But any point on the line, if you go up 2 and over 1, you'll be right back on the line. That's what that slope is telling you. And you can remember this, you always go, whatever the bottom number is, you always go that far right. Top number, that's how far you go up, but if it was a negative, like if the slope was negative 2/3, the negative on top means you go down. So either go up or down, and then the bottom, you always go right. Alright, for this problem, we have a line, and they show us 2 points marked on it. And we want to write the equation in slope-intercept form. Now, slope-intercept form means we have just a y on the left side, and that's equal to mx plus b, where m is the slope of the line. So the number in front of x is the slope, and then plus b, and b is the y-intercept. So that's why I colored those in blue, the slope and the y-intercept, because those are the two things you have to figure out. Your final equation is going to have an x in it, it's going to have a y, but then you'll have numbers here for these two blue parts. And if you look at your points here, they give you negative 5, 0, that's the x-intercept on the x-axis, and this this point is negative 3, so 0, negative 3 on the y-axis. 0 in the x direction, and then down 1, 2, 3. And knowing this, since we can see that just by looking at the graph, we know what this part of the equation should be. So let me take my eraser here. The line crosses the y-intercept, or the y-axis, at negative 3. So that's what we're looking. In slope-intercept form, we should have a minus 3 here. And the other number we need to fill in is the slope. So going back to that previous problem, you subtract the x, when you have 2 points, you subtract the y values on top. So I took this y value minus that y value, -3 minus 0, to get -3 on top. Subtract the x values on bottom. So we can start with that same, we used this y value first, so use this x value first. 0 minus -5, and you get a positive 5 on bottom. So -3 fifths, and that's what you would put in right here. -3 fifths. So that is actually your equation of your line and slope-intercept form. Y equals -3 fifths x minus 3. One thing I want to mention, looking at these two problems, you'll notice if the slope is negative, so the number in front of x is negative, or the slope of the line is negative, the line will be going downhill. If you were looking at from left to right, you're going down. Because as I said before, the number up, when it's negative, that means you go down, and the number on bottom always means go right. So like on that last problem, we had a positive slope, so the line went uphill from left to right. So positive lines will go up and negative lines will go down. So if somehow you get your numbers backwards, you may get the wrong sign here, but you can look at your picture and say, wait a minute. Like let's say you got something backwards here and got a positive 3 fifths instead. Like you had those things flipped around. You would say, wait a minute, that's wrong because this line's going downhill. I know it needs to be negative. So keep that in the back of your mind if you have a picture. The slope is going to be negative if it's going downhill, positive if it's going uphill. To look at this one, first we have this written in standard form, the equation, and they want us to change it to slope-intercept form, which means do the y by itself, and then identify the slope and the y-intercept. So I've worked it out here. You would start by subtracting this from both sides. So you get the -7x over on the right side now, and then divide everything by -7. So the -7 will cancel out there and just leave you y. The -7 cancels out there, just leaves you 1x. And then divide this part by -7 as well, and you get a -3/7. So now we're in slope-intercept form. This number right here is the y-intercept. Remember, we have y equals mx plus b. So our y-intercept is -3/7. So right here, so we want the y value is -3/7. That's a negative sign there. Kind of blends in with the fraction bar, but -3/7. And then the number in front of x is the slope. Well, there's just no number showing up here because we don't write the 1. This is really a 1 times x. So our slope is 1. Or again, if you want to think about it, it's 1 over 1. It means you're going to go up 1 to the right 1 on the graph. Here we have a line in slope-intercept form. The slope is 1 over 8, and the intercept is 2 on the y-axis. And they want us to change it to standard form using a positive coefficient for x. So that means the number in front of x needs to be positive. So actually A, C, and E are the only possible answers because D and E, or D and B here, have negatives in front of x, and it wants us to use a positive. So out of A, C, and E, it's going to be A here. We started with this, y equals 1/8 x plus 2. Start off by 1/8 x from both sides. So you get a -1/8 x on the left now. And then we got to change this coefficient to a positive number, which means we're going to multiply everything by a -8. So the -8 times -1/8 will give you a positive 1 here. -8 times y gives you -8y, and then a -8 times 2 gives you -16. So we have no fractions here. We have all integers, and then the 1 in front of x is positive. So that is what we were looking for. And this is called standard form when you have the x and the y on the left side, and then the plain number is off to the right side. And our last problem here, we have 2 points, and they want us to actually not just find the slope between those points, but the entire equation of the line. So you do want to start off by finding the slope. So you take the y value of the first point, subtract the y of the second. That gives you 20, and then take the x value of the first, subtract the x of the second, and that gives you negative 5. That reduces down to negative 4. So remember, y equals mx plus b. Our slope, is negative 4. We can plug that right in, and we're almost done. We just have to figure out what is the y-intercept. Where does this where does this line cross the y-axis? And we don't have a graph to just look at it and see what the value is. What we do here is we take either one of these points, and it doesn't matter which one, and plug it in here for x and y. So I'll just choose the first one, but you can use the other one if you want. So the y value is 15, and that equals negative 4 times x, which is negative 1, plus b. Alright, so now if we solve this down, we'll be able to figure out what b is. 15 equals 4 plus b, subtract 4 from both sides, b equals 11. And you would have got that same answer if you plugged in a 4 and a negative 5. And so with b equals 11, we have our answer, negative 4x plus 11. That's the equation of a line that goes through these 2 points. It's going to cross the y-axis at 11 and have a slope of down 4 over to the right 1, down 4 over to the right 1.